So, hello. We want to solve this problem, which is a cycling tour lasts for 15 days. The total time for each competitor is recorded on an array called times, and after each days of race, the array of entry for each competitor is increasing. So you're going to update the value of time. That basically we're going to be adding all the individual cyclers time for each day. And then from those 150, we're gonna do a ranking of the first 10, which is the fastest. Now, we're going to do a modification of this because we don't want to enter 100 times, 150 times, and tens, which is a lot. We can create a random function for that, as one student did, but let's try to keep it simple first, and then you can modify from there. In order to do so, we're going to only have 2 days. We're gonna provide the ranking each of the 2 days, and we're gonna enter only 5 cyclers. The interesting thing that we are adding also is to make sure that the cyclers has a name. For example, you can say position 1 is cycler A with a time of this. Of course, these times may not be realistic, doesn't matter, it's just to sort. So this is a running the program on paper first, where we have, for example, on day 1, cycler A have 1, did the total lap or the total distance in 1 minute, hour, second, whatever. B, C, D, and E. So if you sort it, you are expecting that position 1 on day 1 is A, position 2 is B, position 3 is C, D, and E. Normal. Now on day 2, we're gonna twist it a bit so that we make sure that the sorting is working and that the mapping to the name is also working. So we're going to have these entries of day 2, and if you add them, this is what you get. If you get this, then means that position D, cycler D is on position 1, then cycler E is on position 2, as you can see here. B is on position 3, but not only telling who is in the position, but what is the time that they got in order to make sure that the sorting is correct. So these times will be also displayed. What we want to do is something. This is our outcome. The outcome is, oh, welcome to day 1. Enter the time for cycler A, B, and C. I did it as an Excel so that you can make sure that is correct because we are putting the same entries. So look, after you finish with cycler E, you're going to have the ranking for that day. So you have position 1 is A with a time, I need to change that for A, no problem, you can do that for you by yourself. Then you have 2, position 2, 3, and 4, 5. Now, then it asks you, welcome, in day 2 as well, the entry, they ask you for the entry, you have the entry there, boom, boom, boom. And now look, it do the corresponding mapping and sorting. So it sort correctly, and it map the sorting to the corresponding cycler and put it there. Now, let's go to the code. This is the goal. So let's go to the code. First of all, I have 2 functions that I create in another file called selection sort that will do the sorting, and mapping. Here we use selection sort and no bubble sort because we want to make sure that you can have from a bunch of, let's say, 150 competitor only the first 10. Here we're gonna sort it all because it's just 5 competitor 2 days, no problem, but you can just change that later. That is no an issue. And this is the other function which do the mapping. You send them the sorting time, you send them the time array, you send them the faster in this case, the time array and the cyclers. And what it's going to do, it is going to map, will check who have the 8 on time. Oh, is E, so I will print E. But don't worry, I'm gonna go in detail on that in a moment. So let's go to the main function or the main file here. We have I'm indicating that we have those two functions that I just already explained, and then I jump into the main and say, look, I'm initializing my arrays, no problem, just variable declaration there, and a scanner for reading the input from the user, and the cycler's name, that you can change it, or you can even ask the user to give you the names. That's not an issue at this stage. Now, here is the day. Remember, the day is a big loop that we're going to have, and on each day we want to read the cyclers, update the value, sort, and map. So these four things. First of all, here as it says, it's a loop for cyclers, so we're going to check, because we have 5 cyclers, right? We're going to go from 0 to 4, and we're going to ask, hey, give me the value for the cycler, the corresponding cycler. So it's going to use the array of cycler. And you look at this, here you are adding the input with the previous one. We initialized this on 0, so no problem. The first one will be only the reading, and then from there we'll add it. And here I just want to copy the whole time array into faster array. When you have to modify this for 150 cyclers, you can change this with a 4. You only include the first 10, or you copy all and then you delete the remainder that you don't need, or you just print the first 10. Doesn't matter. So here you have, I read the input of the cycler time for that day, and I copy them faster. Now I want to sort, but I want to sort fastest. I don't want to sort time, because I want to keep time as original value, so I can map the position 0 correspond to the cycler A. So I go do my sorting, calling my function sort, and I send the faster. So if I go to sort, what it does is basically get an array, run the array from 0 to the last position, and first of all take the first one as a minimum, and then it check if there is something that is minimum than that. If there is something that is smaller than that, it put it on the minimum position, and like that organize the array. As you say, if you want to change it to descending order, ascending is because we want the faster minimum value, so that's why this is ascending. If you want to change it to ascending, if you want to change it to descending, you just change the symbols here in the comparison. You want it to be maximum instead of minimum. So you want to put the minimum in the correct position. If you find one, you want to put it in the correct position. If not, you just continue dating. So basically we'll compare the first one with all of them. If there is someone that is minimum than the first one, you're going to put it in the minimum, then going to compare it with all of them. After there is not, it will jump to the next position and we'll do the same thing. So I finish my sorting. After that, if I go back here, I say, okay, I have the time, which is disorganized. I have the sorting, which is organized, the fastest, which is organized, time. Now I want to map the organized position, which is the first position, time, with the corresponding cycler. And that we do it in the function mapping. Again, we send them the faster, the time, and the cycler. So in mapping, when you receive those 3 arrays, it will go, sorting array is faster, just is to identify that is the corresponding one, the one that have the sorted value already. So I want to go from the first sorting position. I want to compare which position in time, which position in time has the same value as the first position in sorting. When I found that, boom, 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 that's an alert. So that told me, hey, position 4 has the value that you're looking for. Okay, so then please print that the position 1 is the cycler on the position 4 with a time on the position 1. So this is what is going on here. So after that, you will tell, like for example, in each of the day you enter your values, first day, then it's gonna say, okay, position 1 has a timer of 1, a time of 1. Who has that time? Oh, it has the position 1 because we didn't change anything, 1, 2, 3, 4, 5. So it will say the position 0. So it will say, okay, who is the cycler that have that value? Oh, it's A. So position 1 is A and have a time of 1. And from there it continue. In day 2 is the interesting thing. Since you enter different values here, so it will say, okay, let me add all of this. Boom, and it added and it sorted as we saw here. So in day 2 we have this. So after you sort it, you will have 9, 11, 15, 9, 11, 12, 15, and 20. So it will say 9. Okay, let me check on time. Who has the position 9? Or which time have the position 9? Sorry, which time have the value of 9? So it will go to, oh, is D. And it will say, then D is a position 1 with a time of 9. And is what we can see on our program here. In this case, sorry, I put another value for E because this is done well here. I put another value or D for D. I put 3, I think. Yes. So you have A first, you have E and then D. Okay. Not D, D. So, and that's it. That's what the program does. I'm sharing the code, but now you can understand the code based on our explanation in the video. Please remember to close the scanner so that you don't have just the scanner open all the time. And that's it. Every block of code is divided by this indicator so that you can focus on what part you don't understand or if you have any problem. Cool.